Hi, my name is Chris Boehner with FLIR Systems. Today I'm going to show you the new ESeries camera from FLIR for quality assurance and point-and-shoot research and development applications. We're going to take a look at a printed circuit board and look at traditional ways of measuring temperature on it, spot pyrometers, and compare that to the value of the new ESeries offering. Let's take a look. Here we have a printed circuit board. We've removed the top so we can take a look at all the different components when we turn it on and how they heat up, both large and small. We can then use that to compare our traditional ways of measuring temperature, such as a spot pyrometer, to our new ESeries camera line. The first thing you'll notice is that the spot pyrometer is very easy to use. I point it and I get a temperature reading out. A common misconception though is that the two laser dots that show up are where I'm measuring temperature. In reality, the temperature measurement is dependent on the distance of my spot pyrometer to my device. The farther I move away, the larger the area that I'm averaging for my temperature measurement. This makes it challenging to get accurate temperature measurements on devices with small components, such as our printed circuit board. In addition, to record the data, I have to handwrite this down or enter it into an Excel spreadsheet on a PC. That's not very easy to do, it's a laborious task, and it makes it tough to really share the data with other people. It's not very exciting. Let's take a look at the ESeries. With the ESeries, all I do is point it at the device, focus, and I get a gorgeous IR image. 19,000 points of measurement with the push of a button. For each pixel on the image, I get an accurate temperature value, making it easy to measure temperature on even large and small devices. For some simple image enhancement, I can use the touchscreen LCD, go in and change the color palette. Let's use high contrast rainbow color palette. Now I can really see the detail in the temperature characterization on the board. If I want to measure temperature directly on the ESeries, I go back into the menus and I can choose from a box or a spot measurement tool. Let's grab the box. I'll move it onto this device over here and now I can get a temperature measurement of the maximum temperature within the box. I can also get the minimum or the average. Let's add another measurement tool. This time, let's grab a spot measurement. I'll move the spot on the device that I want to measure. And now I get a temperature value again up in the top left corner. This camera also features a 3.1 megapixel visible camera as well. Let's take a look at that. If I open up the menu, click on Camera, and let's choose Picture in Picture. Give it a second to catch up, and now we see a beautiful IR image, but also our visible image. This is really nice when you're sharing data with clients or colleagues because it allows them to see the actual device in the visible image, but also see the infrared embedded inside. Now, if I want to save this image for analysis later, or again to share with other clients or colleagues, I simply pull the trigger. I have the camera set up to capture the IR and the visible image simultaneously, so we can reference those later. We now see the image, and it's stored onto my removable SD card. Now that we've captured the image, if we want to download it for further analysis or to share with other people, we can plug in a USB cable, remove the SD card and plug that into our PC or laptop, or send it wirelessly to an iPad or an iPhone with the FLIR Viewer app for further analysis or to share with other people. Makes it really handy and very easy to quickly share data or continue to do further analysis. We simply plug in a USB cable to our PC and we're able to view the image live, do data logging, as well as some data trending. Let's take a look. Now that we've tripod mounted the camera, it's looking at our printed circuit board. We cabled up the camera via USB to our laptop. Let's see how to connect. I simply go to Camera, select, and the computer is going to go out and find all the cameras that are connected to it. Here it sees the ESeries, so I select it and then click on the Connect button. In a few seconds, I get that gorgeous IR image streaming directly to my laptop. If I want to change the color palette, I go to View, Palette, and I can choose from any number of color palettes available. Let's try this 1, 2, 3, 4. There, that looks great. I can also adjust the level and span by simply clicking on the ends and moving left and right along the image enhancement toolbar. I can also go back to From Image to Auto Scale. Let's look at how to collect data. I go under my recording conditions and I see that I can record to disk. We'll turn on our printed circuit board and watch it heat up over that 10-second period. I created a folder of where to store the data called ESeries under the Data folder, and I gave it a name, ESeries Printed Circuit Board. I click OK, and now I'm ready to record some data. I'll go ahead and click the record button at the same time that I turn on my printed circuit board. While the data is being recorded, the image freezes to help optimize and make sure that we record every frame coming across from the camera. Now that we've recorded some data, let's go ahead and open up the movie file and do some analysis on the imagery. We do this by going to File, Open, and there we see our ESeries printed circuit board movie we recorded. Let's open that up. It immediately starts playing back. We can play forwards, fast forward, backwards, or fast backwards, or we can even jump to the beginning or end of the movie. For analysis tools, we have a box, a circle, line, bendable line, spot, and a few other options. Let's grab a spot tool. Put that right on here on the hot resistor, and let's grab a box as well. And we'll put that on the other hot resistor. We can now view the data using the statistics viewer or a temporal plot. Let's grab a temporal plot. I can then dock that to the right or below the image. Let's dock it to the right. Let's also grab the statistics viewer and view that at the same time. In this case, I can dock it above, below, to the right or left of the current temporal plot. Let's put it below. Now let's play through our data. We're seeing the maximum temperature in the box as it plots out. We can log this data to a text file, or if we want to export the imagery as a bitmap, we simply go to File, Export, and we can choose from a comma-separated value file or a bitmap. Let's export the entire image, include the image border and the color bar. We'll choose a location to store it at under our ESeries folder, and then click Save. I now have that bitmap that I can now email to clients or colleagues. With a simple click of Camera, Connect, I can get back to my streaming live imagery and immediately begin collecting data again. For more information on FLIR's ESeries camera package, please contact your local FLIR sales representative. Thanks for joining me today.